Okay, now let us think about one more you have studied in your strength of material. So it is a revision of that particular concept. Now we know that for any material it can sustain maximum stress, which we called as a stress is defined as it is the largest stress obtained when the load applied on test specimen. So this is the definition of ultimate stress that we know. One more stress that is important for us, which is basically used in our ductile material, is the yield stress. It is the stress after yielding start in the specimen, which is tensile type of loading. Next to this yield stress, ultimate stress and yield stress are the maximum stress that we know. Depend upon that, we can design our any component. But these are the ultimate point. Every material may or may not go up to ultimate or yield stress because there may be chances that there are a variety of different aspects on which these two stresses are dependent. So there may be chances that your material may have some kind of cavities, some kind of defects, or some kind of material changes, or some kind of different types of lacunas. That's why it may or may not reach up to ultimate or yield stress. So that's why you cannot rely directly on this. You cannot say that every material has got this much capacity. That's why we are going to introduce one more stress. So that stress you can now see on the our presentation. So that stress is working stress. What is working stress? Working stress is the stress that we have considered for our safe zone. Our material cannot fail, it should not fail. So whatever forces that are applied on that particular material, it should sustain safely. So that is called working stress. So what is that working stress? Working stress, it is the stress which is lower than the maximum ultimate stress, which can sustain without failure. So this stress is also called as a design stress, safe stress, allowable stress, permissible stress. It is one and the same. Now I think you must understand what is difference between maximum, ultimate or yield stress and working stress. Now let us come to the factor of safety. The definition of factor of safety is it is the ratio of maximum stress to working stress. The factor of safety mathematically we can say maximum stress to working stress. So maximum stress is obviously ultimate or yield. In some of the cases, in some of the material, yield point is the failure point, which we call as a ductile material. And in some of the cases, ultimate point is the main cause, main stress that we can observe, that is brittle material or ductile material. So that means the factor of safety is different for ductile and brittle material. In case of ductile material like mild steel, yield point is clear. Factor of safety is equal to yield point stress divided by working or design stress. In case of brittle material like cast iron, the yield point is not defined clearly. Ultimate stress is the main stress that we must consider for the selection of factor of safety. Obviously, one thing is very clear here, the factor of safety is always greater than 1 because yield point by working or safe or design stress. Working or safe stress is that we have considered below ultimate or yield point. So below the magnitude, the quantity or the safe stress that we have considered is having less than our yield point stress. So that is the main thing. Factor of safety is always greater than 1. So how to select factor of safety, that we'll see now. So the factor of safety is depends on following factors. Number 1. So it is depends on material and its properties. Obviously, if the material is having yielding, if the material is having ultimate, if there is a change in the property, what kind of behavior that material gives, depend upon that your factor of safety has to define. It is also depend upon whatever accuracy or test result that we have considered for that machine part. So whether the properties that you know are very accurate, then only we can go for more risk. Otherwise, we have to consider more factor of safety. It is also depends on what kind of load is applied on that particular material. If you don't know about the load, you go for more and more factor of safety. Go for safer side. That means you must consider very less working stress. If you know exactly what kind of load is there, then you can go for a lesser factor of safety or you can take a risk. If you know what is the exact mode of failure, so it may be tensile failure, it may be compressive failure, it may be shear failure, it may be bending, or it may be combined. If you know that particular mode, you can go for a less factor of safety. Otherwise, safer side, you go for more factor of safety. So that is one more consideration. Whatever assumptions we are going to consider, depend upon that also, that factor of safety is depends. If you assume that there is a uniform material, then obviously if you assumption is correct, then you can take a lesser factor of safety. But the uh, assumption is not correct, then you should not take risk. So factor of safety is also depend upon different kinds of assumptions. Assumptions may be in terms of stress, it may be in terms of roughness, it may be in terms of material properties, compositions, type of surfaces, cross type of cross section, stress concentration, and all. So there are different kinds of assumption can be possible. Wherever there is a localized stresses mean pointed load is there. If there is a pointed or acute load, then you should not go for less factor of safety. We must consider safe side higher factor of safety. Just like in case of gears, in case of your cam and follower, or in case of your ball bearing of ball. So there is a localized stresses. The factor of safety is also has to consider when there is a initial stresses. Initial stresses means what? For example, there is a nut and bolt. So that nut and bolt has to tighten. If I tighten that particular nut bolt, then obviously there is the initial stresses created inside that particular bolt. Or in your machine component, there are some particular component which are forcefully come together. Then obviously they are already in stress. So that are called initial stress component. So such type of stresses, if they are in your material, then you should think about more factor of safety. You should not take less, or that means you should have lesser working stress consideration. The factor of safety is also directly related with what is the failure occur. If the failure occur and because of the failure of that particular component, there is a loss of human being, there is a loss of any living organism, then you should not go for lesser factor of safety. If there is a, just like if you take an example of a steel rope which is used for lift. So if there is a sudden breakage, obviously because of the sudden breakage, the complete lift may fall down, and because of that there is a loss of life. Or if you think about a bridge structure and the ropes which are used for bridges. So if you think about the failure directly causes loss of life. So in that case, you should not take risk. You should go for higher and higher factor of safety. Here, one thing is very clear. If I increase the factor of safety, the working stress or the safe stress value is going to reduce. It is having direct inverse relationship. If there is a loss of property, that also directly related with our factor of safety. If there is a loss of property because of failure of component, you should not take risk. You should have a lesser factor of safety. Okay. So these are the different conditions for selection of factor of safety. So this can be asked for 6 marks, or it can be asked any four consideration for 4 marks. So it's very simple thing, I think. So this is all about the consideration. Values of factor of safety. As we know, the values of factor of safety is also depend upon what kind of load is on that particular and what is the material. Now here you can observe a material and different kinds of load. As here steady load is having lesser value of factor of safety. If you go for live load, the factor of safety is going to increase. If there is a shock loading, if there is a shock loading, again there is a more risk, so factor of safety is going to increase. So here working stress, if you just think about the working stress, in steady load condition the working stress is having more value, live load is having intermediate value, and if you think about the shock load, in that condition that particular uh, working stress value is very less as compared to steady and live load. So if you take any material, materials are here cast iron, wrought iron, steel, soft material, alloy, leather or timber, you'll find that in all these materials, so factor of safety is going to vary. Obviously, if you compare steel with timber or leather, for any kind of load, the factor of safety is less than the timber. Why? Because steel is more reliable, steel is having somewhat uniform properties, and it is having good strength. So that's why the factor of safety also we are going to consider lesser than the teamwork. So this completes our topic of factor of safety. So it can be asked for 4 to 6 marks. Now